Okay, hello everybody. Welcome to Conceptual Physics today. So last little bit of our notes. So it's just this last PowerPoint, and then I'll have a lot of math examples on this video for you, so you can succeed with that, hopefully at a distance as well as here in class. Okay, so you guys have heard about hang time, right? So Michael Jordan used to be like the king of hang time, which would mean that he could jump higher than anybody else. It just seemed like he was hanging in the air, floating around. So this is kind of going to drive our discussion today. So be thinking about basketball and the NBA. Okay, so here's just kind of some notes. An object shot or thrown in the air will accelerate at a rate of 10 meters per second for every second of traveling upward. Okay, that's it's a reiteration of some of the notes that we had yesterday. But the big thing that you have to remember is the whole time something is going upward, it's accelerating, and when it stops at the top, it accelerates and then comes back down and gets faster. So that whole entire time, the key to remember is that it's 10 meters per second. Every second, the acceleration is. That's what we call little g, or acceleration due to gravity. And we typically put a negative in there, even though it's not in the questions a lot of time. We put it negative because we know that it's in this direction, it's downward. And we said yesterday and the day before that by convention, upwards is positive and downwards is negative. Just like to the right would be positive and to the left would be negative. And I'm reiterating that again because it's really important to know that and remember it when you're doing your math so you can get the math correct. Okay. Here's the second note here. It says the object's velocity will decrease at a rate of 10 meters per second due to gravity. That's a complete reiteration of what we've been saying before. But for example, and you can do this math in your head, if an object's initial velocity, so if you look at this a little closer, if you have a ball that has an initial velocity of 30 meters per second, it will take 3 seconds to get to the top where the velocity is 0 meters per second. Because you start at 30 and you decrease by 10 every second. So after 1 second, take 10 out of 30 and you'll be at 20. After 2 seconds, you'll be at 10. Then finally, after 3 seconds, you'll have taken all of that velocity right out of that ball. And so it'll take exactly 3 seconds to get to the top if you start with 30. Now we're using 10 for gravity just to make this math a little bit more understandable, and we use it in physics, AP Physics 2. Because the important part is that you understand what acceleration due to gravity is doing. So on the other hand, you know, if you start a ball up on top, your initial velocity is 0. So, you know, this ball is going up, and this is it going back down. Your initial is 0 meters per second. You know, a little bit later, in fact, 1 second later, you'll be at 10 meters per second. 2 seconds later, you'll be at 20 meters per second. And then 3 seconds later, you'll be at 30 meters per second. So it's a regular pattern, and it's symmetrical. So the way up is just like the way down, except for one thing. All of these velocities will be in the opposite direction that we called positive over here because we said up was positive here. So by default, down then is negative, and that's conventional. When I say by convention, that means everyone just does it that way, unless there's a reason to do it differently. Okay. And here, the second note here is, another example is if the object's initial velocity is 60 meters, it'll take 6 seconds because it's still that change of 10 meters per second every second. So this is what hang time is all about. It's about jumping straight up, getting to the top. Okay, so an athlete's hang time is less than 1 second. Now, I don't know why it says it's less than 1 second, but we'll calculate it to see. In some of the example problems, I think I have more than 1 second, so we'll have to just think that it's a superhero doing jumps. But we can calculate it. So if you know how high, what'd you say his name was? Derek Jones? Derek Jones? If you know how high Derek Jones can jump, we can figure out his hang time. So here's an example. How high did the athlete jump if he or she is in the air for 2 seconds? Okay, so there's a little contradiction here. This statement is saying an athlete's hang time is only 1 second, but the example is talking about 2 seconds. So let's look at that. Okay, 2 seconds. Okay, so what I want to do is every time I do an example problem, I want to make a checklist. And here's the checklist: V subscript naught, V, A, X, and T. And T is what we're looking for here, right? Well, actually, it was given to us 2 seconds. It said if a person jumps 2 seconds, how high? So this X is always the meters. The acceleration is 10 meters per second squared. I'm going to put that negative in there automatically because I know it's little g. Okay. So all these problems we're going to be doing today are going to be governed by this acceleration due to gravity, this little g. Initial velocity, I don't know. Or actually my final velocity, I don't know either. But if I'm just talking about how high I can go, what do you know about hang time? Hang time is all the way up and all the way down. So if someone is jumping up and getting back down in 2 seconds, that means that your time up was how many seconds? Any guesses? 1. Yep. It's 1 second because it's the same on the way up as it is on the way down. So if you get a hang time question, when you use the time, you might need to use it half of it if it's asking how high, because that first second is going to get me to how high I'm going to go. If I go 2 seconds, I'm all the way back down to where I started. So on these hang time questions, a lot of time you have to think about half of the time. That might be the hardest part. Okay, so let's see how high someone can jump. Now, because going up and going down is symmetrical, we can use this formula right here for both. If there's for all these hang time ones, you can use it because they start and stop in the same spot. But we have to treat it like we're dropping, because the reason why we can use this formula like that is when you drop something, your initial velocity is 0. This formula actually comes from this formula, which is what I showed you quickly before. But this piece is 0, and so if you multiply anything by 0, it cancels out, and so then you're left with this formula. And it can be AT squared, GT squared. It's still just acceleration. keep in mind, little g is gravitational acceleration. Okay. So I'll show you. Now that you know where that formula comes from, you can use it. Okay, so let's see how high Derek Jones could jump if his hang time was 2 seconds. Okay, so 1/2 10, it would be -10 actually, times 2 squared. So your height then would be 1/2 of 10 is what? Okay, so -5, 2 squared is 4. So it says Derek would jump a -20 meters. Oh my goodness. I must have did something really wrong here. Let me double check this. Oh yeah. I just realized that I tricked my own self by not doing the right thing. Because the total time of the jump was 2 seconds is hang time, which means that only 1 second to go up. So that's where I screwed up, was right here. Okay. So I'm going to change that because I knew that was just way too high. Okay. So instead of 2 squared, it's going to be 1 squared, which will make a big difference. Okay, so 1 squared is 1. So now it's 5. It's a -5 meters. And the reason why it's negative is because I went up here to the top where my initial velocity was 0. And so when I drop back down from the top, it's actually in the negative direction. So if it asks how high, do it this way. But just know that high doesn't have direction. So you just put 5 meters for your answer. Any questions about that?